Okay, so physics section 3.1 part 5. So we're now going to throw a little bit of a math component, so something that's measurable, into our physics unit. So there are two different equations that we will be looking at for this unit, and this is page 212 in the textbook. You will be provided with these formulas on a quiz. You do not need to memorize them, but you do need to know how to use them. So we're going to break down kind of each variable in the equation, because currently it just looks like a bunch of letters. And we're going to kind of show you how to use them so that you can then do some practice. Starting off with, we have mechanical kinetic energy. So this is symbolized by E with a subscript of K, and it's measured in the units of joules. So the equation overall to calculate this is EK is equal to 1/2 mv squared. So again, measured in joules, which we represent with a capital J, you do have to know these units and you do have to have them memorized. So the description is the same for kinetic energy as it has been for the rest of the unit, and this is just energy of motion. So our next component here, next to the 1/2, is m. So a lowercase m is mass, and this is measured in kilograms. So not in grams, not in pounds, we're working in kilograms here. So if you have some other unit other than kilograms, say you have grams, you do need to convert to kilograms before using the equation. So unit conversions are something that you should be familiar with. You learn it in grade 8 math. It's brought up again in grade 9, so it shouldn't be new. If you are stuck with that, please let me know and I can help you on it, but it is something that is worth reviewing. So description of mass is a measure of the amount of matter in an object. Then we have v, which is velocity. So this is sort of like speed, but velocity is specifically tied to a direction, where speed can be in any direction. So you'll learn a bit more about this if you choose to take Physics 11. So down here at the very bottom of the slide, you do not have these in your notes, so pause here and write them down. If you don't write them down, it's going to cause you a world of trouble, unless you're really, really good at manipulating equations, but you should write them down anyway so you have them. So these are rearrangements or manipulations of the equation at the top, which solves for either mass or velocity if you have kinetic energy. So if you're looking at kinetic energy and you're given the mass or volume, you can use the main top equation. If you were given kinetic energy and mass and wanted to figure out how fast something was going, aka the velocity, you'd use the V equals equation. If you were given kinetic energy and how fast something was going, but you wanted to find the mass of the object, you'd use the M equals equation. So write them down so you have them. But if you are able to rearrange and solve as you go, that's even better. That's ideal, especially if you're hoping to take physics next year. So I'm going to go through how to quickly solve for these equations. So we'll work through them separately. So first off, if we were, say, trying to solve for V, I'm just going to rewrite out the original equation here. Ignore that line there. That's a like the cursor on Microsoft Word. There we go. Okay, so EK equals 1/2 mv squared. So to start, just like in algebra, in order to get rid of that 2 in the denominator position, we're going to multiply this by 2. So that will cancel that out. Whatever you do to one side of the equal sign, we have to do to the other. So now we have 2EK equals mv squared. In order to isolate v by itself, we're going to divide this by m. You could also use a division symbol, either or. Here this m is going to cancel out. So we're going to have 2ek over m, it becomes a fraction, is equal to v squared. Now going back to exponent laws, which you should be familiar with because we're now in the last semester, and this should have been taught to you in grade 9. in order to get rid of a squared exponent, we have to take the square root. So we square root both sides. So this is how we end up with V equals the square root of 2ek over m, which is our final equation. So now we're going to do the same thing for mass. So again, equation to start. Same step as before, I'm going to times both sides by 2 to cancel out that denominator 2. So 2ek is equal to mv squared. This time, because we are solving for v squared, we're going to divide by v squared, divide by v squared. So that will essentially cancel out that one, because anything divided by itself is just 1. So we end up with m is equal to 2ek over v squared. Okay, so that's how we come up with the equations on the previous slide. So remember, for these two equations, they are just a manipulation or a rearrangement of the EK formula. So the EK formula is one of two major equations. These are just variations of that first equation. So now we're going to talk about our second equation, which is for gravitational potential energy, which we shorten to GPE. So the G in this equation is referring to gravity. So subscript G is gravity. So our equation is EG is equal to M, and then there's a big G, delta H. So a few things to know about this equation, and I'll kind of talk you through each step here. This triangle here is referred to as delta, and it's a Greek letter, and it basically stands for change. So change in, and then H is height. So I'm going to talk you through each part here. So gravitational potential energy, we symbolize with E subscript G, measured in joules again, because it's a type of energy, which we represent with a capital J. And again, this is stored energy due to position with gravity. M, again, is mass, measured in kilograms again, kg, and is a measure of the amount of matter in an object. Acceleration due to gravity is what we call a constant, and we represent this by just a lowercase g. It is measured in meters per second squared, and it varies depending on the planet. But on Earth, our acceleration due to gravity is equal to negative 9.8 meters per second squared. So this is a fixed constant, and it assumes there is no friction slowing down a falling object. Even in Physics 11, for the most part, we ignore friction of falling objects, so you just worry about G. Delta H is change in height, so this is how far an object is positionally going to fall. Delta again means change, so the height is measured in meters. So to get this, we're going to take the final position, which is just the final height, and subtract the initial position. So where it ended minus where it started. Always best with these sorts of questions to draw a diagram to help you visualize things. And at the bottom, we have our manipulations of the equations. This equation is a little bit more easy to work with because it doesn't involve a squared. M is equal to E subscript G divided by all of G, the acceleration due to gravity, multiplied by the change in height. If we're solving for change in height, it's equal to E subscript G divided by all of mass times acceleration due to gravity. Okay, and if you're having trouble with any of these equations, feel free to ask, and I'm happy to go through them with you. Again, these, aren't in your notes, so copy them down. Okay, so let's try a few examples together. Again, I believe this is page 213 in your textbook. So we have a 45 kilogram boulder sitting on the cliff that is 125 meters high. So something like this. This distance between the base of the cliff and the rock is 125 meters. And our boulder is 45 kilograms. How much gravitational potential energy does the boulder have with respect to the bottom of the cliff? So we're working with gravitational potential energy. So E subscript G is equal to mg delta H. Always, always, always list out your variables so you know what you're solving for. Mass is equal to 45 kilograms. Acceleration due to gravity, constant, negative 9.8 meters per second squared. Delta H is equal to the final position, which is it's going to be on the ground, so that's 0, minus, and then it started at 125 meters above the ground, so it's going to be equal to negative 125 meters. Rewriting out the equation, Eg is equal to mg delta H, and then we're going to plug in all our values. 45 kilograms times negative 9.8 meters per second squared times by negative 125 meters. So if you plug this all into your calculator, you're going to get 55,125 joules of energy. If the boulder was to roll off the cliff, so this is part B, and fall to the ground, what velocity will it be falling just before it hits the ground? Ignore friction with the air. So at the ground, EK is equal to EP. So kinetic energy is equal to potential energy. So therefore, we can use the value that we just calculated to help us solve for the velocity. So EK is equal to 1/2 mv squared. We have our mass of 45 kilograms. Kinetic energy, which we just solved for in part A, is 55,125 joules. A way you can solve this is obviously using the formulas that I gave you in the last 2 slides ago. But alternatively, you can plug things in and solve algebraically. So I'll show you that. So EK is equal to 1/2 mv squared. So we know that EK is equal to 55,125 joules equals 1/2. Our mass is 45 kilograms. And then times v squared, which is our unknown. So similar to what we were doing before, we need to isolate v. So times by 2, times by 2. You get 110,250 is equal to 45 kilograms times by v squared. Okay, and then we want to divide by 45. Whatever we do to one side, we do to the other. So you end up with 2,450 equals v squared. And then we're not done here. We need to take the square root of both sides. So you're going to end up with your final answer, which is v equals 49.5 meters per second. Again, make sure you have those units on it. It's a good idea to include them throughout your calculation, ideally. However, I know that they can confuse some students, but note that in Physics 11, most teachers want you to include those units. You definitely need the units in your final answer here. Okay, also good idea, box your answers just like in math to show what your final answer is. So take your time with these questions. Make sure you have a scientific calculator as well so that you know how to use the square root button and the squared button. If you need any help with these, reach out to me and I will show you. Get help early for this sort of thing because it's easy to fall behind with. Phone calculators, I personally find to be annoying, and also you're not allowed to use them on tests and quizzes. So get yourself a scientific calculator if you don't have one already. You should have one though from math. That is it for our lesson. I'm just going to skip through. Here's just the same slide over again. There are a couple questions for you to work through in your notes, okay? So I will post the answers for these, but that's it for this section.